Wanted to talk with you about a couple of other projects that the HPC Council is involved with and definitely supporting. And it's more or less going around what I call open platform, which include open source, ability to do things that are not proprietary. I'm going to go a few examples, but we see a very good, from my perspective, a very positive trend moving from closed platforms to open platforms. And open platforms include multiple elements within the term, and I'm going to cover a few of them. But the move to open platforms enable people to do things better than before, enable people to do things that fit for their needs, optimized to their requirements. It enables to create new solutions that were never be able to create before. There is a lot on growing standards, open source, open platform project around that. For example, big data or Hadoop, it's all based on open source, which I think it's a very good thing. Different sterilization for different elements. There is other examples. And most of those examples, I would say not most, but some of those examples are being driven by cloud infrastructure, Web2 infrastructures that would like to go and take platforms or solutions and optimize to their needs. And because of their power, of their capabilities, they also drive those solutions to other and other places. Several examples. ARM, for example, I think it's a good example for open platform, right? ARM, it's an architecture where any company can take and build a CPU which is based on a standard, and we see more and more ARM vendors doing that. Not sure if there is IBM folks here. Here, so Open Power, it's another example. I think it's a great example of IBM going and understanding where the market is moving, and then opening the power architecture, and then other people can go and create power solutions. And it's not only be able to create other solutions, but also ability to innovate and provide better performance and better capabilities. One thing that I was personally involved is another element which is called Open Ethernet. And Open Ethernet, comparing to past solutions from different vendors which they were very close, in a sense that if we were buying an Ethernet switch, it typically came with all the software and all the element, and that's it. You know, take it or leave it. And if you want to bring your own elements, you really cannot. And what we see, a couple of years ago, it's the start of SDN, software-defined network, where people says, well, I do want to optimize and control the routing. InfiniBand, for example, it's a great solution that you can actually go and define the routing. InfiniBand was born as an SDN infrastructure in the sense that there is a software element that controls the entire infrastructure, and you can go and change the routing and do things like that. In Ethernet, you could not. So SDN provided a window into that area, which is a great thing. But now we're seeing more and more solutions going on the Ethernet switch infrastructure, which enable people to separate between the hardware box and then the software element and choose the best of breed. We see more and more open source software to manage Ethernet infrastructures, such as Quagga, for example, which is a layer 3 routing that was established by Google to start providing elements. OpenFlow, OpenStack. There is companies that start to provide software for managing switches or doing the routing, Comulus, for example, PK8. And then you can definitely do your own. So be able to separate between those two, it's a great element to bring Ethernet switch infrastructure to become an open platform where people can innovate. I want to talk a little bit more about CloudX, which goes on the same trend as open platforms. Now, clouds is pretty much the future of the data center. Now, I would be careful talking about HPC and cloud. I think be able to have a system that can be shared by multiple users has been established in HPC for long years before it was called a cloud. And cloud doesn't really mean virtualization, non-virtualization, by the way, but this is a sub-note. But with the increase of the data that we collect, and the data that we generate, we can drive things to make our world a better place. And one example is to create traffic with no congestion, which is a great dream, right? Especially here. But now there is a lot of solution that helps you to look on where the traffic is, and you try to avoid congestion. But congestion, at the end of the day, that's a routing problem. Same as you do routing in a data center. So if you can get information and analyze information of who's want to go to where, you can start create routing within roads and try to eliminate congestion at all. World without crime. So there is the big brother element of there is cameras everywhere and everyone is looking and you watch 24/7. Some people are going to say that there is a negative element here. I think there is also a positive element here. Because if everything is being watched and everyone is analyzing data, people will not do things that they're not supposed to do. So it can help to eliminate crime. Medical support. The amount of data that we collect in the medical area, if you put everything, make everything digital, and be able to analyze all those millions and billions of cases, I bet that there is enough cases that resemble each one of you here. And then if you analyze the data fast enough, and you can analyze the amount of data, you might be able to predict what's going to happen to each of one of you in the next 5 years, and probably I can start giving you medicine now in order to prevent something that's going to happen for you in the future. And many other things. So the question is, how do we bring the data and how we analyze it fast enough and how we create things that can work in real time? And definitely cloud is one of the elements that can drive that one. It is becoming the most important technology in the data center. At the end of the day, and future applications will run on the most efficient clouds. Now, cloud is not an easy thing to build. Now, there is the major companies such as Amazon, Microsoft, Azure, and others that build clouds, which are the public clouds. But also you see companies building private clouds, but it's not an easy task to do. And there are companies that make a lot of money in order to help other people to build clouds. Take, for example, Rackspace. Rackspace makes a lot of money just for helping people to build cloud, because building cloud is not an easy task. So the question is, how can we help making clouds an easier thing to build? And not only that, but also build an efficient cloud that can help reduce IT costs. Assuming you can reduce IT costs by 50%. It's a good number. And not only reducing the cost, but building an efficient cloud that can actually run things in a better performance versus anything else that exists out there. And here is a few cases which are more on the data analytics side, which were tested on infrastructure that we call CloudX, and I'm going to give you a little bit more information moving forward. But you see, for example, Hadoop or Memcached already, so MongoDB showing 2x to 4x performance improvement versus any other cloud that exists outside. And it's not only reducing IT cost or enabling higher performance for different applications, but it's an ideal environment for building the next generations of applications. And there are more and more what we call Web2 applications, which take the data and try to analyze it fast enough and do it in real time and provide great results or great business capabilities. So CloudX is formed on taking the best element from each case and making sure that, taking the best compute, the best storage, enabling to use SSDs, for example, archives, moving every SSD to archives. Ability to access data in a very, very fast way, it's critical in order to analyze data in real time. Data comes from a sensor elements. All of those elements needs to be connected with a very, very, very fast way. And one of the main issues within cloud infrastructures is moving data. Netflix wrote a nice article about their usage of clouds in order to provide movie streams to the end users, and they're going different ways in order to try to get bandwidth and reach end users. because the lack of capabilities of running much faster within the cloud. So they're trying to go into different ways in order to do things. So one of the key things that we believe that you want to bring into the cloud infrastructure is a very fast interconnect. Ability to leverage offloads and other things that can save your CPU cycle, so you can have more CPU cycle crunching the applications, and ability to reduce the cost of moving data within the cloud infrastructures. So CloudX is based on open cloud architecture, which means that you can take elements in each area. If it's from the hardware perspective, the software perspective, you can take open source, you can take commercial elements, and with that open architecture, you can build a cloud that fits your needs. One of the things that we're involved in is creating the recipes for CloudX. So CloudX is pretty much a platform. It's a recipe that other people went and built and provide a recipe to everyone else that want to build a private or public cloud. And the only thing that they need to do now is just go step by step. So as I'm starting to figure out what to do next, you get a complete recipe that enables you to build a complete cloud, a very efficient cloud step by step. One version of it is based on OpenStack, which is an open source element. We think that there is more and more companies that are playing with OpenStack. There are also companies that start to provide commercial solutions based on OpenStack. Red Hat, for example, is doing so. Mirantis is another company that providing a solution based on OpenStack. Where we're involved in OpenStack is, again, taking OpenStack, installing that on complete cloud, and then figure out where's the missing elements. And then bringing that back to the community as an open source solution. As well, there is a large ecosystem around CloudX, where you can take, for example, OpenStack from Red Hat. There is a recipe that you can use Microsoft OS. There is a recipe that you can use other software elements. If it's for managing, if it's for virtualization, if it's for security, if it's for other things. But the entire ecosystem is there that enables you to pick elements that you want, go according to the recipe, and you can build a cloud in a very easy way. One portion of the project here is the ability to provide OneClick Cloud. So if you decided that you want to go, for example, with OpenStack, there will be companies that are going to give you the entire software, which you can take the entire software, and instead of building cloud in weeks, months, you can go and do it in a very quick way. So you can get a software, one click, you can go and produce a cloud. Now, there are more and more CloudX infrastructures that are being built around the world. So besides of the recipe that people can get, and besides of the one-click software you can take and put it and build a cloud, there is also cloud infrastructures being built around the world that enables people to go and log in and access and see how it goes, see how it works. Works for them, not works for them. There is already one in the US, there is one in Israel, there is one in China. There is more being built right now in Taiwan, a couple of other places in the US, and one in Europe, I think. But there is more and more CloudX infrastructures that enable people to get access and start using CloudX. So overall, I know that I didn't take all the 30 minutes that I have. So it's a good part. We're going to have a longer break after the 2 sessions from now, I guess. But the notion about CloudX is to make cloud an easier way. So if you look on HPC, it's pretty much the same thing. So in the past, HPC was a complex task. And there was the big SMP machines that people bought. And if you wanted to increase the system size, you need to buy a new machine. It's like if you want to bring a new refrigerator to your house, you need to build a new house, more or less. And then there's the trends of the era of using commodity clusters. So you can buy servers, buy networking, buy storage, connect it together, boom, it works. That made HPC much easier. Cloud is in the same era right now. So cloud is not an easy infrastructure to build today. And the whole notion of CloudX is to go and make it easier for people. So providing the recipes, building the ecosystems, building system infrastructure around the world that people can access. This is a project that is running right now and enables, and with the goal to enables making cloud much easier to build, easier to use, and accessible by more and more people. So that's it. Happy to take questions if there are. Thank you very much.